the two-sample t-test for the population mean. We need two independent random samples, and these samples come from populations which are normally distributed, or we assume that they do. The population variances are unknown, but we assume they are equal. This condition must be met for the t-test. And you may already have shown this, that the variances for the population are equal, by accepting H0 in a two-sample f-test for variance. We start with two populations where the population variances are unknown, but we are assuming that they are equal, which we can prove if we need to, using a two-sample f-test for variance. So we take a sample from each, and we work out the sample mean and the sample variance. And then we calculate the pooled sample variance value using this formula. So SP squared. So this is the common population variance to both. And this value then feeds into our test statistic formula for the t-test. We're using this pooled estimate for the variance to estimate the population variances, which are unknown. The formulae are given on page 12 of the AQA formula book. Example 1, we have two samples. The first has a sample size of 7, the second a sample size of 6, and we're going to calculate this pooled estimate of the population variance first. So entering the data for April into the calculator, so we have the sample mean, option 4 for the standard deviation, which we need to square to get the variance. So 54.30 squared. So this value here goes into this part of the formula, that's a variance, so we're squaring. So this is the SP squared value, the pooled estimate for the population variance. We're testing at the 5% significance level for any difference in the mean yield. So this is a two-tailed test. So we have H0 and H1. For the t-distribution, to get the number of degrees of freedom, we're going to use this little formula here. So add the two sample sizes and subtract 2, which is this value, so it's 11. The cumulative probability to the left of this line is 97.5%. With 11 degrees of freedom, we go to the tables. 11 degrees of freedom, 0.975. Our critical value is 2.201, and it's a two-tailed test, so it's positive and negative. And in the t test statistic formula, this value is 0, which is why it's useful to write h0 and h1 in this form rather than this. So 0 goes into the formula here. Our SP squared value from here. So our test statistic is 1.5 and it's in the acceptance region. And our conclusion in context. Example 2, we have our 2 random samples. So we're going to calculate the SP squared value first, the pooled variance value, like this. So it's 18 degrees of freedom. We're assuming that the times come from independent normal distributions with a common variance, so those conditions are met. It's a 5% significance level, and we're testing to see if root 2 is quicker on average than root 1. So a one-tail test. So we have this, that 2 is less than 1, or we can say that the mean of 1 is greater than the mean of 2. Or the mean of 1 minus the mean of 2 is greater than 0. So we have this positive difference which makes the test a bit easier. And this is the large value minus the small value to give a positive difference. So from the tables, looking up 95% with 18 degrees of freedom, 1.734 is our critical value. So our test statistic T will use this value from H0, which is 0 here, our SP squared value that we've already calculated, our test value is 1.72, which is less than 1.734, so we're going to accept H0, and our conclusion in context. Example 3, because we've got this summarized data in this form again, we have to use the formula on page 12 in the formula book, which is here. Working out each sample variance and then the pooled sample variance value. We have degrees of freedom, so 17 degrees of freedom. Calculating the test statistic, this value is 0. Looking up 17 degrees of freedom with a probability of 97.5% from the t distribution tables. (2.110). Our test value of minus 2.67 is less than minus 2.11, so we're going to reject H0. And the conclusion in context. And the assumptions for the test. We assume that the samples are random samples from normal populations with equal population variances.